So, hello everyone. Welcome at our inVision Tech Talks. We're back. We had a break with our webinars, but now we have 4 webinars in 2 days. So everyone has the right topic, I'm quite sure. Our today's topic will be high-speed visions. We've got 3 presentations by Euresys, Baumer, and Infratech. If you have any questions, just use the Q&A section and we will answer your questions after each presentation. At the end, there will be a final Q&A session, so everyone has the chance to ask everything he like. We'll see if our presenters are able to answer every questions. I hope so. I'm quite sure they will. And Jean, I think now it's time for your presentation. After 10GbE, now we have a presentation about CoaXPress, the other leading high-speed interface. And maybe, Jean, you can tell us a little bit more about the new possibilities of CoaXPress.
Okay, thank you, Peter. And good morning, everybody. Welcome to this Euresys presentation. So today we talk about high-speed vision. And I will try to convince you that CoaXPress is the most appropriate interface for reliable high-speed vision applications. So I will start this presentation with a small introduction about Euresys, what we are doing and who we are. Then I will briefly introduce the CoaXPress interface standard. Of course, the main part of my presentation is about the benefits of CoaXPress for high-speed vision applications. And I will conclude with a few words about the future of CoaXPress. But first, let's talk about Euresys. So we are manufacturer of machine vision components. Euresys is a Belgian company. We have R&D teams in Germany and in Belgium. Euresys has sales and support offices in Europe, in USA, in Singapore, in China, and in Japan. There are more than 70 people working at Euresys, and half of us are in R&D. Euresys also benefit from an extensive network of distributors, and we are renowned for providing high quality products and providing premium support to OEMs and system integrators. So at Euresys, we provide 3 types of product. We are very well known for our frame grabbers that have been used in the vision industry for more than 30 years now. But in addition to frame grabbers, we also develop and produce IP cores for FPGA programmers. So IP cores provide a quick time to market for the implementation of various interface standards like GigaVision, like CoaXPress, like USB 3 Vision, or MIPI CSI2 into hardware devices such as cameras and frame grabbers. We also develop and provide a complete range of machine vision software libraries that are known as OpenVision. And those software libraries, they are used for the development of 2D, 3D, or deep learning-based applications. So now let's talk a little bit about CoaXPress. So CoaXPress is the best standard for the machine vision industry. So some people may argue that GigaVision is the best standard, and I would say that GigaVision is probably the most used interface in the machine vision industry. And in terms of number of cameras, GigaVision is probably #1. But when it comes to high-end application requiring high frame rate and high resolution, I believe that CoaXPress is now the market leader. CoaXPress is an interface standard for camera and frame grabbers. The latest version, namely CoaXPress 2.1, was released in February last year. Something very important that proves that CoaXPress is really well adopted by the machine vision community is the fact that more than 50 companies in the world are providing cameras, frame grabbers, and accessories for CoaXPress. So CoaXPress is used to acquire images from the fastest and the highest resolution cameras. Over a single coaxial cable, it's possible to transmit up to 12.5 gigabit of raw data, which corresponds to a net transfer of 10 gigabit per second, which is exactly the same bandwidth as a 10 gig camera. So with this coaxial cable, you can not only transmit data, image data from the camera to the frame grabber, but also send commands, send triggers to the cameras. CoaXPress has a no jitter, low latency triggering capability, and using the same cable, you can also supply power to the camera. CoaXPress use robust connectors for reliable connection, and the latest generations for CXP12 speed, CoaXPress use micro BNC connectors. In terms of cable length, at the maximum speed of CXP12, you can reach 40 meters. And of course, you can use longer cable for lower speed. At Euresys, the frame grabber that are compliant with CoaXPress are gathered under the name Coaxlink series. And here we have an overview of our offer. Of course, I will not go in detail through all those boards. This is not the subject of this presentation, but just remember that we have a CoaXPress frame grabber for 2, 4, and 8 CXP6 connection, and 1, 2, and 4 CXP12 connections. So we really cover the whole range of possible application for CoaXPress. Now, let's talk about the benefits of CoaXPress for high-speed vision application. We have asked our customer why they are using CoaXPress in their application. And based on the answer, 5 main reasons came out. I will now review all of them one by one, explaining why CoaXPress is the most suitable interface for high-speed vision applications. The first one is, of course, the high bandwidth requirements. So nowadays, there are sensors and cameras available that require a bandwidth up to 40 gigabit per second. And those cameras, they are readily available today. I remember a few years ago, the most popular industrial vision cameras for machine vision, they feature 5 megapixels. Then we moved to 25 megapixels, then 45 megapixels, and now we are at 65 megapixels with frame rate up to 70 frames per second. All those cameras, they are using CXP12 for 4 CXP12 connections. They are even much higher frame rate camera. And we have an example here below. This is an example of a camera featuring 16 CXP12 connectors. With this camera, at a resolution of 1280 by 800 pixels, the camera can provide more than 7,000 frames per second. And if we reduce the size of the image down to 128 by 8 pixels, we can reach more than 700,000 frames per second. So this is pretty impressive. As you can see, CoaXPress is really used to interface the highest resolution and the highest frame rate cameras. So at Euresys, we have made tests with our Coaxlink frame grabber at 1 million frames per second, and it works perfectly fine. So on the host PC side, such a high camera bandwidth means a huge amount of data to process. And very often it's necessary to use several PC to be able to do the processing. And at Euresys, we provide several ways to do that. The first one is the implementation of the CoaXPress data forwarding feature into our Coaxlink Quad G3 DF board. DF stands for data forwarding. This board allows to distribute the image processing workload among several host PC. The data coming from the camera is split in 2 streams. One stream goes directly into the host PC memory, while the other stream is forwarded to another Coaxlink Quad G3 DF board. So those boards can be daisy-chained, as we can see here. The camera is connected to the first board, and the data is forwarded to the other card in the system. The system is simple, it is efficient, it is very reliable, and it is also cost-effective because it does not require any additional accessories, such as switch, hub, or repeaters. So all the host PC receive exactly the same data at the same time without any delay. Another feature is the data sharing. It has been introduced in CoaXPress 2.0, and it allows cameras to transmit its image data to several frame grabbers plugged into different PCs. So we can see here bottom, in the bottom, we can see some configuration on how the camera can split its data. Data sharing is a feature of the camera, and data forwarding that we have just seen before is a feature of the frame grabber. Both have exactly the same goal. It is to distribute the image processing workload over several PCs, over several hosts, actually. So very often we have been asked why CoaXPress is the most suitable interface for high speed, for high bandwidth application, and how do we compare to other standards. CoaXPress is the leader for high speed application because it easily supports link aggregation. The core speed of CXP12 is the same as 10 dB. So with a CXP12 link, you can transmit up to 12.5 gigabit of raw data. There is an overhead of 20%, so it means that the net transfer is 10 gigabit per second, which is exactly the same bandwidth as a 10 gig camera. So what makes the difference here is the ability for link aggregation. Most of the CoaXPress cameras, they use 4 links, with some of them featuring 8, and as we have seen previously in this presentation, some also feature up to 16 links. On the contrary, link aggregation is very difficult with GigaVision. And most GigaVision camera today, they feature only 1 link. So this is one of the reasons why CoaXPress is so successful with high-speed vision applications. Then another requirement is the support of multiple camera application. And this is also something where CoaXPress can help. So here we see different combination supported by our Coaxlink octoboard. So the Coaxlink octoboard feature 8 CXP6 connection. This is very, very useful. For instance, you can connect up to 8 cameras to a single board. And this is very interesting for applications that require multiple cameras. Using a single Coaxlink octoboard, which is plugged in a single slot of your PC, you can connect 8 cameras. So that's really interesting. And of course, there are different possibilities for the connection of combination of the camera connection, as you can see here. So this interface is very, very flexible. We still have a lot of customers that are still using camera link cameras. CoaXPress is actually a bit like camera link. It's a great upgrade path from camera link, especially for applications that require multiple cameras. With a single CXP12 link, it has more bandwidth than a camera full, actually. And it has also the advantage to use a single coaxial cable. So with the application that we have here in this system, we see that we have 4 camera link full cameras that are connected to 4 frame grabbers. Of course, they use 4 slots in the PC. And CoaXPress can easily replace this system by 4 CoaXPress CXP12 1-link camera that are connected to a single Coaxlink Quad CXP12 camera, which use only 1 slot. So only 1 CoaXPress frame grabber can replace 4 camera link frame grabber. So in this kind of application, CoaXPress is really the interface to use. When we talk about multiple camera application, most of the time we also have to talk about synchronization. And this is a very interesting feature of CoaXPress, is the ability to very accurately synchronize the image acquisition with several cameras. The synchronization is done at several levels. Of course, there is the synchronization of the camera themselves, but there is also synchronization between the camera and a lighting, or between cameras and external events like triggers. It can be hardware triggers, so electrical signal applied on an input line, or software triggers that are directly generated by the software application. CoaXPress has a no jitter low latency triggering capability. And by no jitter, I mean a very, very low jitter. Typically, it's 4 nanoseconds. The fixed latency actually depends on the speed. It's a fixed low latency in case of CXP12 of 1.7 microseconds. This is part of the CoaXPress specification. So the protocol includes the triggering capability. At Euresys, we have equipped all our Coaxlink cards with a synchronization bus. It's called C2C link. C2C link allows to synchronize cameras that are connected, of course, to the same Coaxlink card, but also cameras that are connected to different cards in the same PC or different cards in different PCs. So as we can see here in this schematic, we have a system where we have 3 cameras. 2 cameras are connected to 2 boards in one PC, and a third camera is connected to another board in another PC. C2C link allows to synchronize all the systems. So at Euresys, we provide accessories, which is called an inter-PC C2C link adapter, which allows to propagate the synchronization signal from one PC to another. So all the triggers that are provided by an motion encoder, for instance, or a presence detector has to be sent to the first card, which is the master. And the master is then responsible to propagate the synchronization signal over the C2C link cable, but also through the inter-PC C2C link adapters. So for this kind of application requiring synchronization, CoaXPress is also very well adapted, and this is why CoaXPress is so successful for high-speed application. Another requirement is for low OCPU loads. And this is something where CoaXPress can also help. So how does CoaXPress compare, for instance, to GigaVision when it comes to the computer CPU loads? CoaXPress is like camera link. It needs a frame grabber to transmit the image data from the camera to the host PC memory. The data packet management is very simple with CoaXPress. It is actually done by the frame grabber or the interface card. This is done actually at the FPGA level, so it does not really involve the CPU for the image processing process. On the contrary, for GigaVision that use standard network interface card, the data packet management is done by the driver. So it means it's done by the host PC CPU, which significantly load the host CPU, the CPU cache, and the memory bus. So for CoaXPress, the image acquisition timing is very stable because it does not depend on the availability of the CPU. And the image acquisition does not slow down the image processing at all. As opposed to GigaVision, where the image acquisition timing is not stable, it depends on the availability of the CPU, and the image processing is significantly slower during the image acquisition. So this is something which is not noticeable when you use only one GigaVision camera, but for a high-end application requiring a high bandwidth, where you need to use a 10 Gig camera, you start to notice this. And if you have a multi 10 Gig application, this really becomes a problem. So this is why in this kind of application, CoaXPress is really the interface of choice. The last point is the acceptance of coaxial cabling. Coaxial cable, it's a well-known technology. So those cables are very reliable, they are flexible, they are shielded by the outer conductor, which make them very resistant to sources of electromagnetic interferences. So as a consequence, those coaxial cables, they are prevalent in different kind of domain of applications, such as medical, vehicle, or aeronautics and aerospace applications. Lots of applications are coming to CoaXPress because they need the usage of coaxial cables. So these are the 5 points I wanted to stress today to explain why CoaXPress is really the interface of choice when it comes to high-speed vision application. Of course, the requirement for higher bandwidth, for higher speed, is a never-ending story. And at Euresys, we are already prepared for the future. We are moving CoaXPress from copper to optical fiber technology. And with our Coaxlink QSFP Plus board, we have replaced the 4 micro BNC connector with a CXP 12 speed with a single QSFP port, which is compliant with 40 gigabit per second optical transceiver. So in terms of bandwidth, a QSFP Plus port is the same as the net data transfer of 4 CXP 12 connectors. And moving to optical fiber allow us to break the barrier of the maximum speed on copper and opens the door to higher bandwidth, such as 100 gigabit per second or even 200 gigabit per second.
1 minute left.
So this is the end of my presentation, Peter.
Perfect.
So right on time.
Perfect in time. So now it's the time for your questions. And first questions, maybe it's answered already. Coax cables are easy to be damaged comparing to Ethernet cables. How can this problem be solved?
So if I don't understand correctly the question, I'm sorry, I don't really hear it. So the question was, is there so concerning the coaxial cable, it can be damaged? That's right.
The question is, CoaxXpress cables can easily be damaged compared to an Ethernet cable, or more easily damaged. Are there solutions to prevent that, to make safe?
So I think it really depends on the cable. So some cables are much more robust than the other. But anyway, if you have a cable which is damaged, in the CoaXPress specification, there is mechanism to check the integrity of the image. For instance, every packet has its own tag. So the system knows exactly if the packets are coming in the correct order. We have also a stream arbiter to check this point using the tag. CRC error is also implemented. So you are directly notice if there is something wrong in the transfer of the image data.
You mentioned an application with 700,000 frames per second. So there's, of course, the question, where's the limit? How many frames per second are possible with CoaXPress?
So as I said, we have reached at Euresys, we have tested our board up to 1 million frames per second. So the limit is not really the number of frames per second. The limit is the bandwidth. So with 4 CXP12 connector, you can transmit up to 50 gigabit per second raw, which means 40 gigabit per second. And this is really the limit. Of course, if we have seen with this presentation, link aggregation is possible with CoaXPress. So we have seen a camera featuring 16 CXP12 camera, 16 CXP12 connectors. So in this case, the bandwidth is even much higher. So that's not really a limit about the frame rate. That's more a limit about the bandwidth.
Thanks. Jean, there's a question about, is there a limit to the number of CoaXPress cards you can put in a PC?
No, there is nothing in the CoaXPress standard that specifies the maximum number. Actually, it's really depend on the number of PCI Express slots that are available in the PC. But CoaXPress does not limit this.
Mm-hmm. And when will you move to fiber optic? How many cameras, maximum can you connect to a single PCI card with 1280 to 800 pixel at 7 kilohertz?
So actually, we already provide frame grabber which support CoaXPress over fiber. So this is our Coaxlink QSFP Plus board. Actually, it depends. So we support QSFP Plus compliant optical transceiver, and there are there are different possibilities. I mean, it's possible to have to connect only one camera with this port, or you can have also, or you can use split cable to connect up to 4 cameras, for instance. So for the moment, it's 4 camera maximum.
Thanks. According to you, what will be the next step for even higher speed?
CoaXPress sites are using CoaXPress over fiber. We have seen that we already reach 40 gigabit per second using QSFP+. The next step is QSFP 28. And in this case, we will reach 100 gigabit per second. The following step will be QSFP 56. And in this case, we can reach 200 gigabit per second. And there is also a version which is the DD version for double data rate, which will allow to reach 400 gigabit per second. In case of CoaXpress, as you know, we have the possibility to distribute the image workflow among several PCs using data forwarding or data sharing. So that's also another possibility. You can use several computers to do the processing actually.
There's not technical question. As COVID is hopefully over, Ukraine war, chip shortage. What is with shipping of materials? Do you have the same time as before, or do you need more time for delivering your products?
I have the same answer as Mirko. It really depends on the product. Some frame grabbers are really impacted by the shortage, other not so much. For the one that are the most impacted, we also try to redesign the board and to use other components, other FPGA, for instance, from other series, to be able to provide solution for that. So yeah, we are keeping that.
So thanks a lot. Hope to see you soon. Please stay healthy and bye.